Let's see the next algorithm, which is selection sort. Now selection sort and bubble sort, they are very close to each other. One small difference is there. So let's understand the algorithm of selection sort with the same example. Suppose these are the numbers 48, 30, 25, 35 and 10. They are placed in an array at 0th, 1st, 2nd, 3rd and 4th position. Number of elements are 5, so range of index is from 0 to 4. Now in bubble sort, what we did in bubble sort, we have compared the consecutive elements. That means 0th position element with 1st position element, 1st position element with 2nd position element, 2nd with 3rd and 3rd with 4th. In selection sort, what we do, we keep the position constant. That means suppose I keep this 0th position as constant position, and then I will compare the 0th position element with every other element in each pass. I mean, in 0th pass, 0 with every other element, in first pass, 1st with every other element, and so on. So first I will compare 0th position element with 1st position element. Now 48 with 30. Now if 0th position element is greater than 1st position element, then I will swap, so that thing will remain same. So the swapping will happen between 48 and 30. So 30, 48, 25, 35, 10. These will be the numbers after swapping. Now after that, I will compare the 0th position element with 2nd position element. So I won't compare this 48 with 25. I will compare 30 with 25. 0th position element with 2nd position element. So that is the difference between bubble sort and selection sort. So this 30 is greater than 25, and I want to sort the elements in ascending order. So if previous element is greater than the next element, then I will swap. So swapping will happen between 30 and 25. So numbers will be 25, 48, 30, 35 and 10. After that I will compare this 25 with 35. Now 0th position element with 3rd position element. So 25 is already less than 35, so no need to swap. Since I am arranging in the ascending order and this 25 is already less than 35, there is no need to swap. After that, comparison will be between 0th position element and 4th position element. So after the previous comparison, the elements are as it is, and now I will compare 25 with 10, 0th position element with 4th position element. So now 0th position element is greater than 4th position element, so I will swap. So 10 will come here, then 48, then 30, then 35 and then 25. So this process is now over, and now it is called as pass. I will number it as 0, pass 0. In bubble sort, what did we get? In bubble sort, we got the maximum element at the end of the array, at the end of pass 0. Now here you will find that I am getting the minimum element at the beginning of the array, at the end of pass 0. So this element is already sorted. The rest of the elements are yet to be sorted. They will go as an input to the next pass. That means 48, 30, 35, 25. This will be the input to the next pass. And now the positions of these elements are 1, 2, 3, 4. So I will compare first position element with second position element. So if I compare first with second, then first is greater than second. So it will be 30, 48, 35, 25. I will swap the elements since 48 is greater than 30. After that, next comparison will be between first position element and third position element, first with third. 30 with 35. 30 is already less than 35, so there won't be any change. 30, 48, 35, 25. Next comparison will be between 30 and 25. So 30 is now greater than 25, so there will be swapping. So 25, 48, 35 and 30. So this will be the end of pass 1. And at the end of pass 1, this 25 is again minimum, which is at the beginning of the array. The rest of the elements, which are 48, 35, 30, they will go as an input to the next pass. So 48, 35, 30. In terms of positions, first, second, third are the values. Sorry, in terms of positions, the values are second, third and fourth. Second position element, third position element and fourth position element. So comparison will be between 48, 35. 48 is greater than 35, so there will be swapping 35, 48, 30. Then next comparison will be between 35 and 30. This one and this one, second with fourth. So 35 is greater than 30, so again there will be swapping, so it will be 30, 48 and 35. This is at the beginning, end of pass 2. Remaining elements are 48, 35. In terms of positions, they are third position element, fourth position element. Swapping will happen in the comparison, and at the end of pass 3 you will get this element which is minimum. Only one element is remaining, which is automatically sorted. So number of passes which we required are 4. So again, if number of elements are n, which is 5, then the maximum number of passes which are required are n minus 1. That means 4. So I will require 4 passes. So if I draw the similar table as I have drawn in the bubble sort, it will be something like this: 0th pass, first pass, second pass and third pass. n minus 1 number of passes ranging from 0 to n minus 2. So this variable I will call it as I variable again, which will represent the pass number. Now in 0th pass, which are the elements I am comparing? In 0th pass I am comparing 0 with 1, 0 with 1, 0 with 2, 0 with 3 and 0 with 4. So here the comparisons are 0 with 1, 0 with 2, 0 with 3 and 0 with 4. In the first pass I am comparing first with second, first with third and first with fourth in terms of position. So first position element with second position, first with third, first with fourth position element. In next pass, second position element is with third position element and second position element is with fourth position element. In the next pass, third position element will be compared with fourth position element. So this variable is I variable, and now this left hand side will be also I, because this is 0 0 0 0, which is same as this 0. This is 1 1 1, so this is same as this one. That means that left hand side is also the I value. So I will take this right hand side as J value, so this will be J variable. So now I will try to write a code. So what will be the range of I and J? So one for loop for I variable. So I variable is starting with 0. I variable is going till 3 value. 3 value means it is n minus 2. N is 5 in general. N minus 2 is going till n minus 2. That means I can write I less than n minus 1, or I have to write I less than equals to n minus 2. I plus plus. So this will be the range of I. Then J. Now J is starting with which value? So here if you see, this right hand side is J, so it is starting with 1 here. So when I value is 0, J is starting with 1. In this pass it is starting with 2, 2, 3, 4. So when I value is 1, J is starting with 2. When I value is 2, J is starting with 3, 3, 4. So in general, J is starting with I plus 1 value. So J, I will initialize J as J equals to I plus 1. J is going till which value? J is going till 4 every time. So in each pass it is going till 4. So in general it is going till n minus 1. So I can say J is less than equals to n minus 1, or J is less than n. So that will be the condition, and J plus plus. So this will be the for loop for J. In that I will compare the elements. I will compare which elements I will compare. This element is represented as AR of I, and this element is represented as AR of J, because this is I variable, this is J variable. So I am comparing AR of I with AR of J, and if the previous element, that means left hand side, if the previous element is greater than, AR of I is greater than AR of J, then I will swap AR of I with AR of J. So code will be temp equals to AR of I, AR of I equals to AR of J, and AR of J equals to temp. So you will close all the brackets. So this will be the code for sorting. So you need to remember these limits, how they are coming. So for that you need to understand this algorithm and this table. So let's implement this code. Let's add another function, which is selection sort, in the same code that we have implemented earlier. So now I will comment out the call for bubble sort, and instead of bubble sort I will call another function which is selection sort. To this selection sort function I will pass ARR, which is array base address, and n value, which is number of elements. So selection sort I will write it here. So void name of the function is selection sort, then it is taking int asterisk arr int n array and size of the array. So here I will declare variables I, j as index variables. Now how do we write in selection sort? Here I take nested for loops, one for I, other for j. What is the range of I? I starts with 0, I goes till n minus 2, that means I less than n minus 1, I plus plus. In that I for loop I will write another for loop which is j for loop. So j starts with I plus 1 in case of selection sort, j goes till n minus 1, that means j less than n, j plus plus. And here I will compare AR of I with AR of j. So here it will be if AR of I is greater than AR of j, then I will swap AR of I with AR of j. That means using some temporary variable temp, I will swap temp equals to AR of I equals to AR of j, and AR of j equals to temp. So now let's compile and run. Suppose there are 5 elements, say I enter some random elements which is say 13, 2, 1, 5, say 20 or say 10. So output is 1, 2, 5, 10, 13 in the ascending order. So I am getting the output. So this will be the selection sort.